Welcome to a brief history of tokens. We will explore how AI learned to read, reason, and charge by the token, from bytes to billions. What exactly is a token? It is the atomic unit of every modern language model, roughly equating to 4 characters or 3/4 of an English word. Tokens are the units models use to read, process, price, and produce language. Tokenization has evolved through 3 main types. It started with character-level tokenization pre-2015, which was simple but led to long sequences and lacked semantic meaning. Next came word-level tokenization, which offered natural boundaries but suffered from huge vocabulary sizes. Today, we primarily use subword tokenization, like byte pair encoding or BPE. The BPE algorithm works by initially starting with characters, finding the most frequent adjacent pairs, and repeatedly merging those pairs until a target vocabulary size is reached. These learned rules are then applied to encode new text quickly. The history of tokenization shows its rapid evolution. After BPE was applied to neural machine translation in 2016, OpenAI adopted it for GPT-1 in 2018, marking the beginning of the GPT era. The following years saw immense scaling, with context windows growing significantly and the introduction of per-token billing. Tokens are the essential currency of AI. They function as a unit for reasoning, billing, and computation. They also set the context limit, act as a memory key for attention, and serve as a metric for quality and throughput. Tokens are the foundation upon which everything in large language models is built. The scale of the token economy is massive, with ChatGPT processing an estimated 1 trillion tokens per day. We have seen costs drop drastically, by up to 1,000 times in just 2 years, while context windows have expanded dramatically, reaching up to 1 million tokens in models like Gemini 1.5 Pro. Problem 1 is the token tax, where inefficiency costs us more than necessary. This includes redundant system prompts, JSON and markup overhead, and retrieval-augmented generation context stuffing, all of which contribute to significant wasted tokens. This redundancy can waste 40 to 60% of a typical enterprise app's token budget. Problem 2 is language inequality, as BPE tokenizers, trained primarily on English, create a, quote, foreign language tax. Non-English phrases often require significantly more tokens than English equivalents, resulting in up to 6 times higher costs, worse model quality, and context starvation for non-English users. Problem 3 is the memory wall. Bigger context requires more GPU memory, leading to slower, costlier, and more limited models. KV cache memory grows, reaching hundreds of gigabytes for large contexts. Furthermore, the standard attention mechanism scales as ON squared, meaning small increases in context size result in large increases in computation. Problem 4 is the cost explosion. Although token pricing has dropped significantly, usage has grown exponentially. For an enterprise generating 1 billion tokens per day, yearly API spend can reach millions of dollars. Token optimization, such as achieving 50% savings, is becoming the #1 AI cost lever for enterprises. We are addressing these challenges with solutions like prompt caching to reuse system prompts, model routing to send tasks to the most cost-effective models, and context compression to reduce conversation history size. Other solutions include quantization, sparse attention for better scaling, and external memory systems. Prompt caching saves tokens by billing only for the user message after the first call, eliminating the need to resend the system prompt repeatedly. Intelligent model routing directs simple queries to cheap models like GPT-4o Mini and complex ones to more powerful, expensive models like Claude Opus, ensuring cost efficiency based on task complexity. Several companies are normalizing tokens. OpenAI's Tick token sets the tokenizer standard. HuggingFace provides open-source infrastructure. Google's Sentence Piece offers multilingual tokenization. Companies like Portkey, Martian, and LLM Lingua are building tools for cost observability, intelligent routing, and context compression. The future path involves universal tokenization, replacing English-biased BPE with language-agnostic models. Continuous batching and speculative decoding will generate tokens 2 to 5 times faster. Finally, native multimodal tokens will treat images, video, and audio as first-class tokens, although video remains a significant current bottleneck. The token concept is expanding beyond text into multimodal domains. Text tokens are mature, while images are in production, using VIT patches. Audio, which uses encodec, is emerging. Video is currently in the research stage. facing challenges with scaling and cost due to the sheer volume of temporal tokens needed. Let's summarize the key takeaways. Tokens are the atom of AI. Mastering them is key to AI economics. Language inequality is a real problem, causing non-English speakers to pay more. We waste 40 to 60% of tokens, but optimization can cut costs significantly. Context is a scarce resource, requiring external memory systems. Ultimately, the future is multimodal tokens, unifying all data types. Thank you. For essential resources, please refer to TikToken for tokenization, Sentence Piece for multilingual support, and VLLM for inference. You can also explore HuggingFace's tokenizers library, LLM Lingua for compression, and Portkey AI Gateway for observability.